Alright, let me get started. First, I will create a data type for the natural numbers, the type of natural numbers. So I'm gonna do that with data. And now I'm going to use the LaTeX input to type the N, letter N. So for that I can do \B and caps N, like shown in the screen right now. So, and then I'll say define it like there are two constructors, two possible ways of making a natural number. We are using the piano natural number representation. So the first constructor is the base case, so it will be the 0 and the successor. So in the case of writing the arrow symbol, what we can do is \2. That is one way. There is also another shorter and perhaps more convenient way, which is a \R. R for write, I guess, and we can use that to write the symbol. Anyway, so we have 0 and successor. So I wrote the type. Now I will ask, okay, I saved it, so the syntax highlighting clicked in. So I will now load this to Agda, and for that I can use Ctrl+C, Ctrl+L, and I got the all done message at the end, as you can see. Yeah, so let me try increasing the size of that one too. Alright, so I have defined the type of natural numbers. So let me try to have an example value. Let's say egnat1. So I want it to be let's say number 2, the number 2. So that I can do like successor of 2, and let me save it and then load it back to Agda. Oh, I'm getting an error. I wonder why. Oh, sorry, I have to do it like this. Yeah. So as we can see, we made example values. Let me say for natural number 2, that will be a more convenient name because we are having number 2. So now that we have a way to represent natural numbers, it would have been more convenient if we could write it in terms of the numerals, the like 1 2 3 4, instead of having to write in terms explicitly in terms of the constructors like successor of 0 and etc. So we can have that part ready in Agda by using this stuff. Say it's built-in natural. And this, using this directive to Agda, we can say that okay, from now on I can use the numerals, the natural numbers, instead of the values instead stand in for values of this n type, this type that we have over here. And okay, let's see if that really works. So if the above directive instruction to Agda worked, we should be able to write 2 in terms of successor stuff. So yes, it is working, so that is fine. There are some internal stuff happening here. So like the book mentions that if you use this built-in natural directive, it internally uses the more efficient representation of numbers instead of having this unary form of representation that we have in the type. So that is something else just to keep in mind. And right, so let me actually try making some functions using this natural number type. So let me just have a function named add two natural numbers. So let me first write the type. So yes, so I have two numbers, and for now I'm leaving the definition unwritten. I'm just writing a question mark in place of the definition. And why is that? Because if I now load it, the Agda will leave a hole in place of that question mark to indicate that that is something that we should fill in now before that definition can be considered complete. So let me just try loading this Agda, and you'll see that there is a hole coming up there with the curly braces with the number next to it. At the moment there is only one hole, that's why the number is 0 there. If there are more holes, there will be hole 0, hole 1, hole 2, etc. That's how it works. Alright, so now time for some shortcuts on the editor. So you can use Ctrl C, Ctrl F to go to the next hole available. So that's what I do now. That's what I just did. And right. And now I need to pattern match on some stuff. How would I do that? So for that I will case split on the number n, the first argument to this function. So I can do case split kind of. The editor will help us do the case split a little bit. If I try Ctrl C, it will ask in the bottom, you can see the pattern variables to case. So I'm case splitting on the first argument, which is named n. So I'm giving n as input and typing enter. So as you can see, the different possibilities, different values that n can take are 0 and successor or some other value, because those are the only two constructors available for the natural number type. So we got two cases, and as you can see there are now two cases for which we need to give a definition, and consequently there are two holes at the moment. So let me again go to the first hole with Ctrl C, Ctrl F. And just for the fun of it, let me go to the next hole with Ctrl C, Ctrl F once again. And I can now go back to the previous goal by Ctrl C, Ctrl B. I guess that's it. Right. So now I need to see, I'm at the first hole. Now I want to see what is the context available to me at the moment to fill this goal. So what are the information, what are the data that we have available at the moment, so that we can use those data to fill this hole. So we can see the available information with Ctrl C, Ctrl comma, and you can see at the bottom, let me wait till that overlay disappears. You can see at the bottom, like there is saying the goal and a line below it, and the context that we have available below it. So the aim that we are what we want to fill this goal with, that is the goal. So that is a value of type n, as we can see, as is shown here. And the context, the data or the information that is available to us with which we can produce that n value is just this. We have m, which is the natural number. So as we know, I mean, if we add 0 to any number, we will get the same number, because 0 doesn't contribute anything to the addition. in the case of natural numbers. And anyway, so we will now fill the hole. So how can we do that? We can press Ctrl C and space, and the editor will prompt us asking what value we should be giving to attempt to fill that hole. So in our case, we are just going to give M, right? That's what we're gonna do. We're gonna give M, and we're gonna press enter, and that hole disappeared. The editor seems to be happy with the value that we used to fill that hole. So we will go to the next hole. So we press Ctrl C space again, and the value we should be giving is successor of something else, right? We are putting another hole instead of, of course we could just give the entire value here, which is successor of n plus m, successor of add nm, but we could also just give another hole there and let the editor prompt us again. That is also a possible way to do it. See, it filled a part of it. It kind of refined it a little bit, and but there is some information that we need to give before or that hole is completely filled. So if we go there, so instead of adding, we could of course do it like add this and etc etc, but oh, what the heck, we'll just try doing that too. Wait, what did I do? Oh, sorry, I did something different. Okay, I will just try to fill the hole. Add. Now go to the first hole, Ctrl C, Ctrl space, N, Ctrl C, Ctrl space, oh sorry, not here. So if we go here, we can see, if we see the context here, we have M and N, but we did not need to use, we already used N in the previous hole, but so we don't need to use it again. So I'll just type I'll just use the M to fill the last hole for this definition. So I will just fill it. Alright, the type checker is happy. The definition of add is complete as far as the type checker is concerned. Let us see if it actually works. So I will just try add 3 and 4. I will just try to evaluate it. Okay, I will show you how we can do that. If you do Ctrl C, Ctrl N, the editor will prompt us for an expression that after we give it, it will try to normalize it, which I guess is a way of saying evaluate it and see the final value. So that is what I'm gonna do now. So I'm just to give so I'm going to give add to 5. So answer should be 7, right? Let us see if that is correct. Yes, we are getting 7 below and over here. So yes, it seems to be working. But remember that just because the type checker set is okay with the definition that we give it, does not mean that the definition that we wrote is 100% correct. The types only guide us. It doesn't actually write the definition for us. The types will guide us, so we heed their guidance of the types, but does not mean that if the type checker says it's fine, that is indeed the definition that we want. The types actually restrict the range of values that we can have, so that we can implicitly rule out some values which are obviously not appropriate. So, but we have to be careful of the exact definition that we give anyway. So the bottom line is that let the types guide you, but don't trust it completely. I mean, don't trust it blindly. I guess that's one way of putting it. For example, in the case of the second case, I could have given 0 instead of n. And the type checker wouldn't have any problem with it. If you try to evaluate the same old expression that we had earlier, add to 5, it would give 6 instead of 7. So the type checker is happy, but the definition is wrong. So just to illustrate that part, so I will go back to the previous definition. Oh, by the way, because we have the pragma, this directive that we had given to the Agda compiler, we could also have written the same add definition like this, like 0m and 1 plus m. Oh wait, no, not yet. Actually, I could have done this too, an infix operation. See, instead of doing that, I could have done this to define this is a way of to define infix operators in Agda. So we could have, instead of writing add, we could have just used this as well to write it, the same definition. Let me try and see if 1 plus, no, that's fine. Alright, that's for addition. Hang on, let's see if it actually works. Yes, it does work, fine. So now we can try multiplication. So I'll just use the infix notation for that. So I'll just use the same way that we had done earlier. So I will load it, so there will be a hole remaining. So I will go to that hole, I will case split on n. So there are now 2 cases. I will go to the first hole. So it's asking what will be the value if I multiply 0 with another natural number. The answer is obvious, it is 0. I will fill that hole with 0. I'll go to the next hole. It is asking what will happen if I do 1 plus n multiplied with m. So the answer is m plus n into m, right? So that is what I'm gonna do. M plus 1 into m. Wait a minute. 1 plus n, no, m plus n into m. I hope I'm not doing it wrong here. 1 plus n into m, m plus n into m. I think it's correct. So I have now defined the multiplication operation for the natural number type. Let me try it out. Let me see. 4 into 5, it is 20. So that seems to be working. So what else do we have left? Oh yeah, right. We have exponentiation operation. So power operator. So let me see, n raised to m is equal to 0, the same way as we had done earlier. I leave a hole, I go to that hole. Look at the context, I have m and m. So I will case split on the second argument this time, because that's more convenient. So n raised to 0 is 1, right? So that is success. Oh, what the hell, I just key 1. And we have n raised to 1 plus m. So that is 2 into 2 raised to m. I mean n into n raised to m, right? So that's what I'm gonna give. N into n raised to m. Oh, sorry. I might have done it different than what I wanted. N raised to 1 plus m is n into n raised to m. No, you have to add a space, otherwise it won't work. So that works. So note that these infix operations always require a space in between its operands, because this won't work. Agda won't be happy, but if you add a space, it will work. So okay, right. Let me actually try using it. Let's see, what is 3 raised to 3? 3, 9, and 3, 27. Yeah, it is working. So what is 5 raised to 5? Oh, I again goofed up. I should have given a space between the operand. Oh, I guess that is correct. Alright, so far so good. Now let's just try subtraction for natural numbers. So subtraction of natural numbers is not as familiar as for the subtraction of integers, because you cannot, once you reach 0, you cannot go to negative values. So the book refers to the subtraction operation as minus. We're using and uses this symbol like backslash dot, this symbol for the minus operation, and we will follow that example. So n minus m is equal to, we will leave a hole here. Let me see, should I case split on n or m? What the hell, I'll just try n. So if you subtract anything at all from 0, there's nothing more you can do. You just have to say 0. And if you well, here it gets a bit tricky, because this is not following the pattern of the definitions for the other definition that we had seen so far. So instead of this, I will just say n minus 0. It will of course be n itself. Oh, so it complains that we didn't take care of some of the cases, possibilities for the arguments. So of course Agda points that out to us, and we have to fix it. So let us see, what are the remaining possibilities. Agda has actually spelled it out for us this time, so we will just do that. Successor of n minus, oh wait, what did I do? Minus successor of m is n minus. That looks right? That looks fine. Let us see. 5. Oh, wait a minute. Let's see. 5 minus 2 should be 3. Okay, it is 3. And 4 minus 10. It is 0. Right. That seems fine, right? So there is one thing that you might want to check out. It is that note that there are for this case 0 minus 0, both these cases match. So there is an overlap between the possible matching here. In this case, both regardless of which match we had, the result is the same. But there may be cases for more complex examples where that might cause problems, because we might miss where the error is coming from. So if you want to avoid that, if you want a clear separation between the matches, we can use a pragma here, which, let me write it out. Options, let's hope I'm writing it correctly. Options, exact split. I think this is actually an argument you pass on to the Agda compiler when we start it up. Or anyway, if you use that pragma, let me delete this part, it will probably give an error. Let me try that. Yes. Oh, useless pragma. Only allowed at the beginning of the file. Oh, right. Let me move it to the beginning of the file and come back to where we were. Alright, see? Exact splitting is enabled, but we could not do that. So what can we do? We can try, we can have only this. So if we have 0, 0 now, we will match only this one. It won't match here. So now it's fine. The expression still valid if you look at the previous examples, they're all, wait a minute, 5 minus 2 is 2, how can that be? Oh, wait, I have not got this correctly. Alright, now that should be correct now, isn't it? Should be, of course it should be. Thank you. Alright, and that's it. So this is all I had planned for today. See you next time. Bye.